Here's the second problem off of our extra transformations problem sheet. So same exact instructions. Indicate the basic function, list the transformations, perform the coordinate analysis, and then sketch both graphs. So first things first, here we are squaring a thing, and that tells us that the basic function was the function that just squares things. Okay? Now let's list the transformations. So having come off of the unit on parabolic graphs or quadratic functions, this should be really comfortable by now. So you notice you have two transformations. You have this -3 and you have this +2. The -3 is a shift to the right. And again, just like in the previous example, let's go ahead and do the coordinate analysis as we go. You'll notice this is really handy because it makes it so that there's no kind of finagling on the graph. You have exactly the information you need to see where every single point on the graph of f will go subject to these transformations. So shifting right 3 units, if you're starting at some random point on the graph of f, let's call it xy, a shift to the right, so the y coordinate is unchanged, the x coordinate is increased by 3. So at the end of the shift right, you're at the point x plus 3 comma y. Then you have that +2 on the outside. So that's a shift up. And again, you've already done the shift right. So you're starting at x plus 3 comma y. And then the shift up will not impact your x coordinates. They stay the same, but the y coordinate gets increased by 2. So you have x plus 3 comma y plus 2. And that's the end. That is where we finish our transformation. So again, you started at some point xy on the graph of f, and then you wound your way down the transformations, and you ended up at the point x plus 3 comma y plus 2. So let's go ahead and graph. Okay, we'll start with the axes. So here they are. Okay, let's label the axes. Always label your axes. And let's start by graphing f. So again, at least 3 points. So it goes through the origin, it goes through 1, 1, and it goes through -1, 1. If you want more points, you can plot more points. Like you can put 2, 4. That's up here. You can put -2, 4. That's up there. So as many points as you need to feel really comfortable that you've got the shape is fine. As long as there's at least 3 of them, I absolutely allow, I have absolutely no problem with you using as many points as you need. So the graph looks something like this. Okay. And again, just remember the graph goes on forever, right? So if you are better served by putting little arrows on your graph, great. I typically don't like putting arrows on my graphs, but that's just my personal taste. You can or cannot agree with me. Okay, so let's see where these points end up. So here are our points x, y on the graph of f. So we have 0, 0. 1, 1, and -1, 1. And again, if you used more, then use more. No problem. The beautiful thing is that coordinate analysis tells us where every single point ends up. Regardless of what point you started, coordinate analysis tells us where you end up. So if x and y are both 0, well then x plus 3 comma y plus 2 is 3 comma 2. If x and y are both 1, like in the last point, x plus 3 is 4, y plus 2 is 3. If x is -1 and y is +1, then x plus 3 is 2, y plus 2 is 3. Okay, again, if you use more points, then you have more points. Up to you, but let's plot these guys. So 0, 0 goes to 3, 2. You can label the points on the new graph, and I encourage that, but I want to keep my explanation as clear as possible. So I'm going to leave the labels off of the graph, but I have the labels in my little sort of pseudo table off to the right. Okay, so 3, 2 is where 0, 0 went. -1, 1 goes to 2, 3. And 1, 1 goes to 4, 3. So you can see actually quite clearly that you're fleshing out the exact same shape. Oops, there we go. And so to the best of your ability, and this is actually one argument for using more than 2 points, the more points you use, kind of the more precise your picture, but to the best of your ability, keep exactly the same shape. So there is the new graph. So again, in blue we have the original function, in green we have the transformed, and we have checked off all of the items on our to-do list. We have indicated the basic function, we have listed the transformations, we have performed the coordinate analysis, we've sketched both graphs, labeling at least 3 points. All right, that's the second problem. See you soon for the next one.